So first thing I have to remark is that I'm not going to talk about the meaning of life. I think that's some question that has to be answered by each individual. But I'll just talk about how the post cancellation occurs, which happened in Nikita's lecture. Maybe not in very detailed manner. So let me first recap some definitions. We had the y observable, y of x, which is the E symbol of E minus EX S lambda star. So this is evaluated lambda. So I think this is the Chan class evaluated X for the tautological sheaf. And Nikita gave the expression of this in terms of the Jeong diagram in Jeong diagram lambda. My epsilon will be always epsilon 1 plus epsilon 2. Do you remember this? Okay. So let's first consider the pure n equals 2 theory, which is much simpler. So here we had a partition function which depended on A, epsilon 1, epsilon 2, and Q. This was the sum over the Jeong diagrams, Q to the number of boxes in the Jeong diagram. And some measure. This measure was given by the E symbol of these combinations. I mean, this is the character of the tangent bundle. So Q12 is Q2, P12 is 1 minus Q1 plus Q2. So what I'm going to show you is that starting from the y x plus epsilon, I will compute the residue of it and see how it can be cancelled by adding a second term. So this thing? Yeah. So n is just the rank n bundle. Yeah. So they are all representations of our torus, the torus at T, which has weights, these weights, right? The weights are some combinations of A, epsilon 1, epsilon 2. They are rank n bundle with this trivially. So they're decomposed as the one-dimensional abelian representations. Each of them has with this weight. And K is, I'll just write there. So K at lambda is sum over alpha from 1 to n, e to the a alpha, box in Jeong diagram, e to the c box, where C box is I minus 1 epsilon 1, J minus 1 epsilon 2. So the vectors in K just carry this amount of charge, where for each Young diagram lambda. And we can compute this thing and apply this E symbol and then compute this partial function. So now Y. So Y has a residue. Y has a residue. First, so let me fix the Young diagram that we are dealing with. So we have a, let's say we have a Young diagram. So we have a Young diagram lambda, which is n tuple of Young diagram. And among them, we are thinking of lambda beta. Choose one of the numbers from 1 to n, and I call it beta. And we have some Young diagram here. And let's say we have here so this box is not in the lambda beta, but this specific box is in lambda plus lambda beta. Sorry, d plus lambda beta. Is it clear? So this can be added, and I will define lambda bar prime as lambda bar plus this box. I mean, this box. So that makes, I mean, this is also inside lambda minus lambda prime beta. I add this box in lambda beta and redefine lambda prime as a Young diagram with this box at lambda beta. And then lambda prime at beta now has this box, so I can remove it. So that's my lambda and lambda prime. So now okay, so now residue of this at x equals a beta plus c box, where this box is this box. So first, we can check from this expression that yx plus epsilon has a pole, simple pole, at this value of x, right? Because when x is that, so x is a alpha plus, sorry. So x plus, so first of all, we have to add epsilon, so this cancels, and we have a pole there, because that box, specific box, is in lambda minus beta. And we can compute the residue easily because we just get rid of that specific term and plug in x equals this into that expression at lambda prime, of course. And this, so we can expect this will just become y a alpha plus c box plus epsilon for lambda, right? Because we now don't have that term, so it becomes, the rest of the contribution just become y at lambda. But we have to be careful because lambda plus had this. So lambda plus had these and these boxes as lambda. Sorry, lambda prime had this box and this box in d plus lambda. So these were in lambda plus d plus lambda prime, but they are not in d plus of lambda. Similarly, this specific box is in d minus lambda prime, but it's not in d minus lambda. It's d minus lambda. It's very confusing, but I'm telling something very simple. So it's corrected by some factor, epsilon 1, epsilon 2, epsilon. So this is residue. And we want to cancel this residue by adding some term. And for that, we have to do some computation. Okay. Now let's compute. So symbol E of T lambda prime minus T lambda. So this is the ratio of the measure in the instance operator function between lambda prime and lambda. In other words, E of T lambda prime, E of T lambda. So remember, this was given by, where is it? I erased it. This is given by the specific combination of N and K. Okay, so let me define. Let me define C to be exponential A beta plus C box. So this C is the weight carried by this box here, the vector in here. Then okay, so let me first write this. Then N K lambda plus C star. This is K lambda prime, right? Because I just added the boxes. So this is K lambda prime plus Q 1, 2, and star K lambda plus C minus P 1, 2, K plus C K lambda C star. Then we have to subtract this. So there are some cancellations. So this survives, this survives. And well, this cancels, but we have cross terms and this. And you see that this can be combined with this, or so this can be combined with this. Because, so that they have C star in common, Z in common. So, Oh, I did. Oh, so I didn't write this expression for S. So I'm going to use this S to express this. So right. Okay. So if we consider the following combination. And take the residue at here. Well, sorry, I didn't finish this part. Oh, so this, sorry, so this can be, so using this expression for y, we can rewrite this and this with y, right? Because we know that this is this. So from the first term, we have y of a box, a plus c box, I mean a beta. C box. Y a beta plus c box. So on. And if you think about it, this is -1 minus Q12 plus Q1, Q2 plus Q1 plus Q2. So this -1 actually cancels one term here. That's because y, this has 0 in here at the zeros of this. But remember, this colored box is inside d plus lambda beta. So one term is 0. So one term of this is 0, so we have to take the derivative to cancel this. Yeah. So take the derivative with respect to s and evaluate here. That's how, and by doing so, we can cancel that term, which makes the 0, which makes this term 0, and cancel this term. And we have the rest. This is epsilon 1, epsilon 2. So this is the expression for that thing, this ratio of the measure. And then we use that here. For this, we use this. Then this cancels, I think there's a minus sign. This cancels with this. And this cancels. And this was also for y, lambda, and lambda. This cancels this. All right. So we are left with minus a beta plus c box and lambda minus 1. So it tells you that if you have the expression of q2 lambda prime e t lambda prime y x plus epsilon at lambda prime, its residue at here is equal to a residue at this value of minus q2 lambda. But you have to notice that lambda prime and lambda has one difference in box, number of box. So I write q over that thing, y of x. Because the 1 over y has the residue, which is exactly this. I'm sorry? Why is there a minus sign? Sorry. Yeah. Yeah, so we see that. Oh, sorry. I multiply e of t lambda. So we see that in the expectation value of y of x plus epsilon plus q 1 over y, the residue at this pole cancel with each other, and it's regular in x. So of course this is pure theory. We don't produce any more y's in the numerator in the second term. So this terminates here. But as we have seen, for n equals 2 star theory, we produce two more y's here. Then because those 2 additional y's produce additional poles, we have to iterate this procedure indefinitely. That's why, and for n equals 2 star theory, we have more and more terms up to q to the infinity. But yeah, for a simple enough theory like this, it terminates here. And then, of course, there's a more nice this is just a direct computation for computation of port cancellation. But tomorrow, I think Nikita will talk about the type 2B string theory construction of the QQ character and give argument why certain combination of y observable has regular expectation value. Okay, that's all for my talk.